Today we're going to take some notes on the start of our next unit, which is going to be over polynomials. And we are going to talk specifically about exponent rules today. So if you'll make sure you add that to your table of contents, we will go ahead and start. So just to recap, we did exponents in 6th grade. And things to remember about an exponent. So it is a larger number to a power, which we call the exponent. The small one is the exponent, the big one is the base. The whole thing is called a power. So for example, if I gave you 2 to the 4th power, we would say 2 times 2 times 2 times 2. So remember, the exponent goes ahead and tells you how many times you multiply the base by itself. So we're going to talk about 5 different types of exponent rules today. The first of which is called the product rule. Product meaning multiply. And the product rule says this. It says if you have like bases being multiplied by each other, then you simply need to add the exponents. So an example of this would be if I gave you 2 to the 4th power times 2 to the 2nd power. Well, let's think about what this looks like. 2 to the 4th power, 2 times 2 times 2 times 2. 2 to the 2nd power times 2 times 2. So we're saying 2 times itself 1, 2, 3, 4, 5, 6 times. This would be 2 to the 6th power. Well, the shortcut, if we are applying this rule, is to say 2 to the 4 plus 2 is 2 to the 6th. Okay, so that is why the rule works, because we're just going ahead and we're multiplying that same number this many times. We can also do it with variables. We can say a to the 6th power times a to the 2nd power. So a to the 6th is a to the 2nd, a. So I have 1, 2, 3, 4, 5, 6, 7, 8. A multiplied itself by itself 8 times is a to the 8th power. So if we're using the rule, a to the 6 plus 2 is a to the 8th. So I have a couple more. So we would say, so let's do this one without writing it out. Let's use the rule h to the 4th times h to the 6th. So we would say h to the 4 plus 6. 4 plus 6 is 10. H to the 10th. And that would be our simplified exponent. We can also do this with coefficients. Now with coefficients, I'm going to strongly suggest that you're writing everything out. Don't try to do it in your head, which some of you do. So I have negative 2 ab to the 3rd times 7 a to the 4th b. So the first thing I want you to notice that the a in the first parentheses has no exponent, and the b in the second one has no exponent. If there's no exponent, it is an exponent of 1. So it's kind of like terms. So coefficients do not apply these exponent rules to the coefficients. Coefficients are just that. They do whatever original operation this is. So this is negative 2 times 7, but then we have our exponents, and we can do our exponents rules. A to the 1 plus 4, because we're going to add them, we're being multiplied. B to the 3 plus 1. And now we can simplify it. So negative 2 times 7 is negative 14. A, 1 plus 4 is 5. B, 3 plus 1 is 4. And that is our simplified answer. Okay. Sometimes we're not multiplying with this time sign. Sometimes we are multiplying in a different way. And this one is called the power rule. So it's very similar. The power rule. When we raise a power to a power, it looks like the distributive property. So I'm going to make a little note here, distribute. So what this looks like is we have some power raised to another exponent. So remember, when we have a number outside of a parentheses, we've learned since 6th grade that we're going to distribute it through. So this becomes x to the a times b. X to the ab, that is our rule. So let's do a little bit of practice on why that is. If I gave you 2 squared to the power of 4, well, that means that I need to write 2 squared out 4 times. So 2 squared once, 2 squared twice, 2 squared 3 times, 2 squared 4 times. So I still have 2 times 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 2. So this becomes 2 to the 8th. And the way the rule works is if we distribute 4 times 2, we get 8. Okay, here's another one for you. We can do this with variables as well. X to the 3rd raised to the 4th. So I'm going to write x to the 3rd out 4 times. And I can see 3, 6, 9, 12. So I have x to the 12th. Well, the way the rule works, I'm just going to distribute this 4 inside. 4 times 3 is 12. Sometimes I have more than one thing in my parentheses. So if I have 2x to the power of 4, again, if you have a regular, if you have no exponents, it is an exponent of 1. Remember that invisible 1. So we would write 2x times 2x times 2x times 2x. We're writing it out 4 times. Well, I know 2 times 2 times 2 times 2, so 4 times 2 is 8 times 2 is 16, x to the 4th. So how does the rule work? 2 to the 1st, x to the 1st to the 4th power. So I have to distribute this 4 on both of them because they are inside the parentheses. And I know that 2 to the 4th is 16. Here's another example with multiple pieces. 4b to the 3rd squared. Well, let's try this without writing it out. So I'm going to put my 1 here on my 4. So this becomes 4 to the 1 times 2, b to the 3 times 2. Well, I know that 1 times 2 is 2, 3 times 2 is 6, and I know 4 squared is 16b squared. Here's another one. X squared all to the 4th power. This becomes x to the 2 times 4. 2 times 4 is 8. I put squared up here. I apologize. Let me go back. I had my 6 here and I did not write that. Sorry. 16b to the 6th. Sorry about that. Another rule, our third rule, is called the quotient rule. If you remember, quotient means divide. And the quotient rule tells us that if we are dividing like bases, then we will subtract our exponents. So for example, 2 to the 5th over 2 squared. So this is 2 times 2 times 2 times 2 times 2 over 2 times 2. Well, I know that I can simplify 2 over 2. This becomes 1. This becomes 1. So now I have 1 times 1 times 2 times 2 times 2. Well, the ones don't matter. So I end up with 2 to the 3rd power, which if you apply the rule, 2 to the 5 minus 2 is 2 to the 3rd. We could even simplify that to 8 if we wanted, but we don't need to. Another one might be, if we did with just letters, a to the 3 over a to the 1. So a to the 3 is a times a times a to the 1 is just a. I know that a over a is 1. I'm left with a squared. So 3 minus 1. You can use your rule that way. Let's do a couple without writing them out. I've run out of room on this page. Let me go to my next one. If I wrote x to the 5 over x to the 2, this is kind of like the one we did before. It's just x's, but the bases have to be the same. So 5 minus 2, this is x to the 3rd. We can also do this with some coefficients. So I can say 12 x to the 7th over 4 x to the 3rd. Now remember, coefficients, we just do what it says. This is just 12 over 4. Then we have like bases, so x to the 7 minus 3. 12 over 4 is 3. 7 minus 3 is 4. 3x to the 4. Right? Our fourth rule is called the negative exponent rule. When we talk about the negative exponent rule, it means that exactly what it says. We have a negative exponent. And that means that we are going to have to take and put this in the denominator. So this is 1 over x to the a. I'm going to talk about why that is. And we're going to make a little t-chart here before we do an example. So I'm going to count down 1, 2, 3, 4. And I'm going to write 3 squared. Well, I know that 3 squared is 3 times 3. And technically, there is a 1 there. 3 times 3 times 1, which is 9, which we don't have to write out. If I wrote 3 to the 3rd power, it's really 1 times 3 times 3 times 3. I can go up. 3 to the 1st power is just 1 times 3. 3 to the 0 power, which will be our last rule, but we can preview it here. Look at what's happening, right? Here we added a 3. We had 3 3s, 2 3s, 1 3. If I have a 0, then I just have 1. If I have 3 to the negative 1, well, then I have 1 times 1/3. So, or 3 to the 1st on the bottom. So that is where this negative exponent rule comes from. So let me show you how this works. If I wrote 2 to the 5th over 2 to the 8th, and we wrote this out. So we would have 2 times 2 times 2 times 2 times 2 over 2 times 2 times 3, 4, 5, 6, 7, 8. And I know 2 divided by 2 is 1. 1, 1, 1, 1. All I have left on the top in my numerator, 1 times 1 times 1 times 1 times 1, 1 over 2 times 2 times 2 is 2 to the 3rd. So if I did my rule, I would say 2 to the 5 minus 8, 2 to the negative 3, and if it's negative, it goes in the denominator. This is why, because if you have a negative exponent, it is less than 1. Here's another example. A to the 3rd over a to the 8th. So I have my a's, 1, 2, 3, 4, 5, 6, 7, 8. These all become 1s. So I am left with 1 on the top, 1, 2, 3, 4, 5, a to the 5 on the bottom. And my rule would look like 3 minus 8 is negative 5, and negative 5 means it goes in the denominator. Let's try a couple without writing them out. So I could have x to the negative 4 means this goes in the denominator, and the exponent becomes positive, x to the 4th. I could write 2